This session, let us continue where we stopped in the previous section. We were discussing about concurrency or concurrent execution of programs on by a computer. Right. So, with the knowledge that you gained from the previous session, uh, we have termed a new word called process, which means a program currently under execution. Any program. And when you say program, it is not a Java program or a C program or a Python program. It is anything, any task that you perform on your computer. Once you switch on your computer, any task you perform, you may create a folder on the desktop, or you may create a new Java file. You may create a new Word document. You may create a new PowerPoint presentation or a PDF document, whatever it is. You may open a audio file and play it using some media player, or you may play a video also using the same media player. So anything, any task that you perform, that is a program. And when a program is under execution, we call it as a process. And for a program to be executed, the program must be loaded from the secondary memory to the primary memory. Right? Secondary memory means hard disk. Primary memory means the RAM. Only then we can execute a program. Right? So all these things we have discussed in the previous session. So now let us understand more about concurrent execution or concurrency. What is concurrent execution? So when a program is executed by the CPU or the processor, we'll use these two terms interchangeably. Actually, technically speaking, the processor means only that the processor chip, which is embedded on the motherboard of a computer. It actually is comprised of some set of CPU registers and some arithmetic circuits for performing arithmetic operations, and logic circuits also for performing logical operations. So that part only together we call it as a processor. And when you refer to the word CPU, it refers to the entire cabin in which the motherboard is placed along with the hard disk, the RAM, the processor, and all. But in operating system context or in some computer science engineering context, we refer to CPU and processor to interchangeably, right? So when I use the term CPU or processor here, you have to understand that CPU is nothing but the processor, and we'll refer to memories like registers, RAM, ROM, cache memory, and hard disk separately. Will not include them in the processor. Actually, they must be included, technically speaking, but they'll not be included in our discussion. Okay, so when the CPU uh, executes a program, it requires many resources. Or let us speak in another way: when a program has to be executed by your computer system, your computer system utilizes many resources that are part of the computer itself. That means what? A program has to be executed, or a process. Now I'll be using the term process instead of program, right? So for a process to be executed, it requires some resources, right? So what are these resources? First of all, the process must be saved in the RAM, or it must be loaded into the RAM. So RAM is one resource. Okay. Then it'll use some input. Your program may take some input from any input device, or it may generate some output also and display to the user by using any of the output devices. Right. So it also requires some input and output devices for completing its execution. And it may refer to a file which is located on your computer. Then it requires CPU time. CPU time means the processor spends some time for executing its instructions. Program is nothing but a set of instructions, right? So each instruction will be executed uh, separately. All the instructions together will not be executed at a single go by the CPU, because the CPU can execute only one instruction at a time, because it is only one in number. If there are multiple CPUs, then we can execute more than one instruction at a time. But because there is only one CPU in any personal computers, uniprocessor system, because the majority of the computers that people use in this world are uniprocessor systems. So we need to discuss in that context, keeping in mind the uniprocessor systems. So CPU can spend or execute only one instruction at a time. So that means what? CPU will execute only one instruction which is part of one process at a time. It cannot execute two instructions of two different processes simultaneously, right? So, uh, how this execution takes place? The CPU will not be executing all the instructions of a process at a single go, one after the other, and then go to another program. Instead, it switches. It will switch from one program to another program. So now, for example, I'm utilizing this notepad, right? So now this is in active state. And at the same time, uh, we are also having a video lecture here, online video lecture here. My audio device is also working. My microphone is also working to receive the sound and send it to you. So how all these things are happening simultaneously means these are not actually happening simultaneously, but they are happening because of the concept called concurrency. Right? In order to display this notepad on the screen for the user, we don't require any input device or an output device. But to receive the uh, voice from the user, we require a input device, that is a microphone, right? And to see something on the screen on the other side, we don't require a output device on this computer, but it is located on a different computer. So we require there an output device also. So when these are happening and these are done, the receiving of input is done by the input device, and delivering the output is done by the output device. So meanwhile, the CPU or the processor can process instructions. It can perform some arithmetic operations or logical operations in a program, right? In that way, each of this resource will perform a different kind of activity. Not all the resources will do the same task. RAM will not perform any arithmetic operations or logical operations. Input and output devices will not perform any operations. Even files also will not perform any arithmetic and logical operations. Who will be performing arithmetic and logical operations? Only the CPU, right? Input and output device will be performing in IO operations, and RAM will be storing the process itself. And the file will contain some data which can be given as input to your program, or the output generated by the program will be written onto the file. So this file actually physically represents the hard disk of the computer. Right? In that way, different resource will have different purpose. Just like in yesterday's example, how we have taken an examination. Uh, so one person in the resources for writing the exam are the paper, the pen, the pencil, eraser, all these things. So you'll not be using all the resources at a single time, right? When you're using pen, you'll not be using the pencil. When you're using pencil, you'll not be using the pen. Similarly, when you're using pencil, you'll not be using the eraser also. In that way, no student will use all the resources at a single time. Similarly, no program or no process in computer science or in operating system context will utilize all the resources at a single time. Sometimes it may utilize, but not always. So taking this point into view, we can share these resources with multiple processes. We can load the processes into the RAM or the primary memory or the main memory. And at one point of time, if one process is using, say for example, it is utilizing CPU time for performing some arithmetic or logical operations. At the same time, some another process which is also residing in the RAM for execution may be utilizing an input device or an output device to take input or to give output to the user. Right? So in that way, resources sharing will be done between among all the processes that are currently loaded into the RAM. So in at this point of time, when I'm using my system, I'm using a PowerPoint presentation, right? I've opened a browser, and browser has many tabs, and I've opened a notepad and typing something in this, and I have opened even the uh, file folder, all these things, all these programs. Now this folder window is one program or one process because it has been opened. Now it is temporarily loaded into the RAM. Even this folder is also another. This window is also another process or program, and notepad is another program, and this browser window is another program, and this PowerPoint is another program. So these many programs are now currently loaded into the RAM because I opened all of them. But currently, what I'm using, which window I'm using, the Notepad window. So this Notepad is currently in an active state. The remaining all programs are in a passive state. They are, although they are in the RAM, they're not utilizing my CPU at present. Right? They are in a suspended state. They are in a suspended state. They are in the RAM only, but they are not actually running. We can call them as they are in a running state, but they are not executing currently by the CPU. So currently, which program is being executed? The Notepad program, which contains some text information in it. And if I switch from this Notepad and open this PPT, then that means now currently this is running or executing. This PowerPoint presentation program is running or executing. In that way, switching will take place between multiple programs that are residing in the RAM at a single time, right? So this is how programs get executed on your computer system. So this type of running the programs is called as concurrent execution of programs. And if any hardware, if any software supports this concurrent execution of programs, we say the concept as concurrency. So your operating system of your computer must support this concurrency in order for you to do all these operations simultaneous. It appears to be simultaneous for the user, but it is not actually simultaneous. We have to use the term concurrently. The programs are executed concurrently. So this is nothing but called as concurrent execution of program. Now that if you understand this concurrent execution, then we can go into the actual multi-threading concept in Java. So what is multi-threaded programming? So you can observe the point. We have already discussed this first point in a previous session. A multi-threaded program contains two or more parts that can run concurrently. That means what? We were earlier in the notepad when we were discussing, we were referring the term called process, right? So these processes can be further divided into multiple parts, right? So process can be further divided into multiple parts. That is nothing but called as threads. So many number of threads together will form a single process, right? So we can say process is an entire program. It is a heavyweight program, whereas thread is a lightweight program, right? Uh, so what is the difference between process and thread? We'll discuss. Thread is one part of a process. Okay. So those two parts, two or more multiple parts, are called as threads. And if you are able to execute two or more parts of your program concurrently, then that is called as multi-threaded programming. Multi-threaded programming. So look at the second point. What does it say? Each part of such a program is called a thread, and each thread defines a separate path of execution. So these parts will be executed separately. They'll not be executed as a single entity. Instead, they'll be divided into the program or the process is divided into multiple parts, and each of those multiple parts will be executed in a separate context, in a separate path. So that is the meaning of separate path of execution, right? So thus, multithreading is a specialized form of multitasking. What is multitasking? Multitasking means performing more than one task concurrently by your computer, hardware, and software together. That is called as multitasking. And this multitasking can be done in two ways, right? So let us discuss about that multitasking also briefly and then go into the actual multithreading concept. So what is the process and thread? First, let us discuss what is a process and thread. A process, in essence, is a program that is under execution or that is executing currently, as I told you earlier, right? Whereas a thread is a lightweight process. Why do you call this thread as a lightweight process? Because thread is one part of the process. If you consider the entire process, it may be occupying more amount of space on your computer. But when you take only part of the process, how much space does it occupy? It will occupy only space, right? So that's why we use the term lightweight process. A thread is a lightweight process, right? Then coming to the types of multitasking, we were using the term multitasking earlier in the first slide, right? Multithreading, multithreaded programming, or multithreading both means the same. So, what is multithreaded programming means? It is one type of multitasking. So, there are two types of multitasking. One is process-based multitasking. The other one is thread-based multitasking. What do you mean by process-based multitasking, and what do you mean by thread-based multitasking? Both will be performing multiple tasks concurrently, but there will be a difference between process-based multitasking and thread-based multitasking, depending on what task is being performed. What is the difference? So, for better understanding, let us go into the next slide. So, look at the point, the first point here. Process-based multitasking is a feature that allows your computer to run two or more programs concurrently. So that means what? We know what is concurrent execution. Concurrent execution is nothing but CPU and all the resources will be shared by multiple processes that are loaded into the RAM. And at one point of time, if one process is utilizing the CPU time, the other process may be utilizing an input device, and some other process may be utilizing an output device. So in that way, all these program processes will be currently under execution, but will be utilizing different resources for their execution at that point of time. So in that way, if the processes are executed by sharing the resources of the computer, then we call it as concurrent execution, as we discussed in the introduction, right? So when you say process-based multitasking, it means that processes are there will be multiple processes, and all those processes will be sharing these resources concurrently, and they'll be executing it concurrently on the computer system. For example, process-based multitasking enables you to run the Java compiler at the same time that you are using a text editor, right? So I'll be opening my text editor notepad, and here I'll be typing my program, and I may also use my compiler simultaneously. So that is how concurrent execution takes place, right? So that is one example for process-based multitasking. Now, in this example, Java compiler is one process, and Notepad or the text editor uh, we are mentioning in this point is another process. Two processes are currently under execution. One is a Java compiler, the other one is a text editor. So they both are currently are concurrently under execution. Right. So in process-based multitasking, a program is the smallest unit of code that can be dispatched by the scheduler. Scheduler is a part of the operating system of a computer. It is going to decide which process to be executed by the CPU at this point of time, and which process will be allocated CPU after this current process, which is utilizing the CPU. next. So there will be something called scheduler, which is part of your operating system, right? So that is going to decide which process must be given time for utilizing this CPU first, and which process must be given next after that. So in that way, it will give a token system like kind of a thing. So just like token number one given to one process, token number two given to another process, like that. So based on the number of the token, the first token number which is held by one process, that will be given chance to utilize the CPU time first, and the process will be interrupted in middle if it requires another resource uh, along with the CPU. It say for example it requires some input from an input device. So until the process gets that input from the input device, it cannot go ahead with further execution of instructions in its process. So it has to be suspended temporarily, and then the chance will be given to another process which is waiting in the queue, that will be given a chance. So that means switching will take place. So switching will take place between two processes by the CPU or by the resources. So this is how process-based multitasking works. So switching will be in between multiple processes. But coming to the thread-based multitasking, instead of having multiple processes concurrently being executed, there will be a one process, and that process will be divided into multiple parts, right? And each of those part is called as a thread, and switching will take place between threads, and thread will be scheduled instead of operating system scheduler scheduling process. It will schedule the threads of a single process or program, right? Program or process can be used interchangeably. So in a thread-based multitasking environment, what happens? A single program can perform two or more tasks simultaneously. For instance, a text editor can format text at the same time that it is printing. So now if I open the text editor notepad, whatever I'm typing here, the value that I'm typing, the key that I'm typing from the keyboard will be processed by the text editor, right? And at the same time, the whatever key I have typed, that will also be displayed on the screen. So these two tasks are being performed by the single process, that is the notepad window, right? But this notepad has two different tasks. One is receiving the input from the keyboard, the other one is displaying it on the notepad window. So these two tasks can be divided into two different parts, and each part is nothing but called as a thread, a separate thread. So there are two threads in this example scenario. One thread will be receiving and processing the input from the keyboard, and the second thread will be displaying that processed input on the screen simultaneously. So that is an example for multi-threaded, thread-based multitasking. Got it? So the process here in thread-based multitasking, what is going to happen is the resources will be switching between threads of a single process instead of switching between multiple processes. They'll be switching between multiple threads of a single process. Right? I hope you understand. You understood this difference between thread-based multitasking and process-based multitasking. In Java, we will not be using this process-based multitasking. We'll be using thread-based multitasking. That's why the reason for the topic that we are discussing now, the name is multi-threaded programming, or multi-threading, simply multi-threading. Okay, it is not multi-processing, it is multi-threading, right? So if you go into the details of the process-based multitasking features, processes are heavyweight tasks because the process involves multiple tasks tied together into a single program, and they require their own separate address space. Address space means the amount of space that it is occupying on the hard disk and uh, RAM, right? So the total number of locations in the memory that this program is occupying, that we call it as address. And inter-process communication is expensive and limited. Expensive in the sense what? If the CPU has to leave one process and switch to another process, it'll be more expensive. Expensive in the sense it doesn't involve money or something, but in computer science programming terminology, expensive in the sense the amount of time taken, the amount of space used in the computer's memory. Right? If it is more, then we say it is expensive. If it is less, we say it is cheap. Okay, less expensive. So context switching from one process to another is very costly in the case of process-based multitasking. That means it will take more time and it will occupy more space. Coming to features of thread-based multitasking, threads are lightweight. They share the same address space and cooperatively share the same heavyweight process because they are part of a single process and they share the same address space. A separate address space is not required for the threads. Whatever address space is allotted for the process itself, that will be shared by all the threads because all the threads are part of the program itself. And inter-thread communication is inexpensive, and context switching from one thread to the next is low cost. So that's why, because context switching in thread-based multitasking is uh, very less expensive, it involves low cost, and inter-thread communication is also inexpensive. We prefer multi-threading in Java, that is thread-based multitasking in Java. So the thread-based multitasking is also called nothing but as multi-threading. Okay, right. Now that you understood what is a thread, what is a thread in a program, as far as Java programming is concerned, this thread may exist in several states. It may be existing in a running state. It may, at any point of time when you take a thread, it will be when it is under execution by the computer. It will be in any of these five states. It may be in a running state. It may be in a ready to run state. It may be in a suspended state. It may be in a resumed state, or it may be in a blocked state. So, what do you mean by these states? Once the uh, thread is created, it may not be utilizing the CPU time on or any other resources for its execution, right? If it is given a chance to execute, then it will be ready for execution. When it is in such a state, we call the thread is in a ready to run state. And once it is given a chance to execute, then we say it is in a running state, right? And when it is in a running state, if it requires some input operation or output operation or some other operation which does not require the CPU or the processor, then the thread will be suspended and another thread will be given a chance. That means just why it is being suspended, because it will not be utilizing CPU until it performs some other operation called input or output operation. So what the CPU will do is it will leave that current thread and take another thread for execution. Then we say that another thread is now under running state, and this thread which has been earlier in running state has been suspended. So then we say the thread is in a suspended state. When it is in suspended state, it may be performing for other input or output operation that is required to continue with the running or execution of the program or the thread, right? So we say it is in a suspended state. And once it completes that input or output operation, some external operation, then it will be again uh, ready for running. Then it will enter into a ready to run state, right? And when it is again given a chance for execution, then we say it is in a resume state, right? And if it is blocked for some reason, if it is blocked for some reason, that means if it is taking more time for running or utilizing more resources, then it may be blocked. So we say it is in a blocked state. So these state names, running state, ready to run state, suspended state, resumed state, blocked state, different people give different names for these states. In some other context, some people will be using a new state for ready to run state. Then a running state exactly same, suspended state also same, or logged state will be same. Some people will use terminated or dead state. Once the program has completed its execution, we say it is in a terminated state or it is in blocked state in this context because it has completed its execution. In that way, depending on whether thread has completed its execution or it is about to start its execution or it has been suspended for some other operation and all these things, The thread can exist in any of these following states. Okay. Then apart from these thread states, we also should know about something called priorities, thread priorities. When I told you all these threads or all the processes which are ready for execution, which are loaded into the RAM, will be waiting in a queue for their chance to utilize the resources and complete their execution. So in such a case, uh, we need to give the priorities for threads, which thread to be executed first and which thread to be executed next, like this, right? So that is nothing but called as thread priorities. So how do you represent thread priorities in Java programming? Java programming, we use some integer values to specify the priority of a thread. Okay, so each thread will be given some priority. A thread's priority is used to decide when to switch from one running thread to the next. This is called as context switch. So CPU switching from one thread to another thread for execution, then we call it as a context switch. We already discussed about it in the earlier part of this session. So uh, thread priority, what is its purpose? Based on the priority of the thread, the switching will take place, the context switching will take place. So currently, for example, if a thread is under execution, say we call it as thread 1, T1, and now T1 has been suspended for some other operation. Then among all the other threads which are in the queue, which one to you choose from them to give a chance for utilizing the CPU time for running it? It will be decided based on the priority of the thread. Whichever thread is having the highest priority among the other threads which are waiting, that will be given a chance, right? So that is nothing but thread priority. So what are the rules that will determine when a context switch takes place, right? A thread can voluntarily relinquish control. That means a thread has completed its execution, then it will relinquish the control of the resources that it is using. A resource means here what the CPU, RAM, or any other resource that we mentioned earlier, right? So in this context, we'll discuss about CPU only. A thread can voluntarily relinquish control. A thread can be preempted by a higher priority thread. So in two different contexts, a thread can be uh, released from the CPU and another thread can be given a chance for execution. So what are those two situations? Normally, for scheduling these threads, we use some algorithms. We use some algorithms. There are several algorithms based on when the thread has arrived. That means which thread has been created first by your computer, by your operating system, or the application software that you are using, which has been first created. So we can start executing that first. Which came next, that will be given a chance. In that way, as and when the threads are created and loaded into the RAM, we can execute the threads on the first come first served basis also. So that is one kind of algorithm that is used for scheduling these threads for execution by any application software or even the operating system of the computer, right? So there is one such algorithm called round robin scheduling algorithm, based on which each thread will be given a time slot. uh, the time slot will be equal for all the threads. Say for example, one each thread is given 1 second for execution. During that 1 second, how much extent it can complete its execution, to that much extent it has to complete execute. And after the time slot is completed, it has to come out of the CPU and give a chance for another thread, right? Then even that thread also will be given same amount of time. So within that time, if it is completed, it is okay. If it is not completed, then again it has to release that one. So in that way, each thread will be given some equal amount of time. Once all the threads are given in one round, then in the second round, another 1 second will be given for all the threads in the same order in which they appear. So this is called as round robin scheduling algorithm. So once their time slot is completed, so these threads will be voluntarily relinquishing the control. Relinquish means release the control of the device that it is holding. So for example, if it is holding CPU, then the thread has to release that CPU because its time is completed. It has to give a chance for another thread which is waiting in the queue. So this is when a thread can voluntarily relinquish the control by itself because its time slot is completed. It cannot continue anymore. Right? So this is one situation where a context switch takes place. In another situation, a thread can be preempted by a higher priority thread. Sometimes these algorithms may be using the thread priorities. Then if one thread is under execution and a new thread is created, and if it arrives, and if that newly arriving thread has more priority than the currently under execution thread, then irrespective of whether the currently under execution thread has completed its time slot or not, it will be forced to relinquish the control of that CPU and give a chance to the newly arrived high priority thread. It is just like VIPs. So when it normally happens in Indian roads, right? So when on the city roads, if a VIP is coming, all the traffic is put on hold, and that VIP is allowed to go first, and then release the normal public. So that means what? The priority is more for the VIP. When they come later, even though they come later, all the normal public will be kept on hold and they'll be allowed to go first, and then after that, the normal public is released. So in the same way, when a higher priority thread arrives, the currently under execution thread, even though it didn't complete its uh, time slot which it is given, it has to release the CPU and give a chance for the higher priority. So these are the two situations where context switch takes place. Right. So you know what is context switch? Switching from one thread to another thread by the resource. In our context, the resource is CPU. We will assume it to be a CPU. Right. Then uh, we have something else called thread synchronization. So what is synchronization? Synchronization is just nothing but some kind of coordination between multiple threads which are utilizing the same resources or which are sharing the same resources. So say for example, if I'm utilizing one resource, and if the other person does not know that I'm utilizing the same resource, what he'll do, he'll also try to utilize that resource, right? Then what will happen? The other person will not know that the resource is being utilized by me, and he'll be repeatedly attempting to utilize the resource that I'm utilizing at the same time. So it cannot happen. So there must be some synchronization between all the threads. If one thread is utilizing one resource, it must be informed to the other thread so that it will not try to utilize that resource at the same time, right? For example, for better understanding, you can take a bank account, a joint bank account operation. So each of these joint account holder. So you know what is a joint account holder? Two or more people can operate from a single bank account, right? So let us assume that uh, both are utilizing the internet banking or some facility and trying to transfer the amount or purchase something online or something. And if I am purchasing, say for example, there is 10,000 balance available in that account, and I'm the first user. I'm the first giant account holder. Some other one of my friend or somebody, my family member, is also the second joint account holder. Say for example, then at this point of time, if I'm trying to purchase something online, uh, assuming that I have 10,000 balance in my account, at the same time I'm purchasing my account, my something online using that account. If the other person also, that is the second or joint account holder, also assumes that he has 10,000 balance there, so he can utilize it, and he also tries to withdraw it using an ATM card, debit card, or he also may try to purchase something online in a different scenario, in a different context. Until one of these transaction is completed and the bank account is updated with the balance amount, the other transaction that is being performed cannot be allowed to perform the transaction, right? So Because it is multi-threading concept and it is concurrent execution of program, and the user has started initiated paying here, for example, the first user, and uh, the initiation, the payment will happen in multiple steps because your program is executed concurrently and it is multi-threaded or multitasking, right? So after performing two steps in this payment, uh, you are suspended, your program is suspended, which performs this transaction and deducts the amount from the bank account and updates the bank account with the uh, balance, fresh balance, right? And meanwhile, that person has also started initiating the payment, and he has completed the payment, but it has not been updated there. It has not been updated in the bank account. So that is a task of another thread, for example, right? So you have completed the payment, that is done by one thread. Another thread may be performing the updation of the bank account balance, and that is not yet completed. And meanwhile, if this transaction is completed here by the user one, then both will be able to use the 10,000. Even though the total balance in the account is 10,000, both are able to perform payments equal to 10,000. So that means what, 20,000. So you will be able to perform 20,000 of transaction even though you have 10,000. So this is a loss for the bank. So what they'll do? So when one person is performing this operation, the other person will not be allowed there. That thread will be locked there until this is completed, and this thread has completed, and that another thread has completed the updation of the bank account. The other person who is trying to attempt make a payment, he'll not be allowed to do that. So this can be done by synchronization. If there is no synchronization between those two processes, there one process and here one process, each process has multiple threads performing multiple different tasks. One thread may be performing the payment and the other thread may be performing the updating the bank account with the balance here on the first user. On second user system, the same way, there are two threads, for example. First thread will be performing uh, making the payment, and then second thread will be performing the updating the bank account. So until both the threads are executed here on the first user, the second user thread must not be allowed to perform the transaction there. If both are allowed concurrently, then some inconsistency will occur, and as a result, the bank will be losing, or the user will not be able to use. Both the users will not be able to perform any payment, even though they have 10,000 balance. Right. So this situation should not occur. So for this purpose, we need some synchronization. Right? So that is called as thread synchronization. Java implements a concept called monitors for establishing the synchronization. You can think of a monitor as a very small box that can hold only one thread. Once a thread enters a monitor, all the other threads must wait until that thread exits the monitor. That means what? Once in our example scenario, if one user is performing, one account holder is performing the transaction, the other account holder is not allowed to perform the same operation there until this one completes it here, right? So that is the meaning of this monitor, and that is how synchronization is achieved in Java programming. Right? Once a thread enters a monitor, all the other threads must wait until that thread exits the monitor. Each object has its own implicit monitor that is automatically entered when one of the object synchronized method is called. So we'll use something called synchronized method and synchronized blocks. So we'll see all these concepts practically by writing some programs, right? So along with this thread synchronization, we'll also see messaging. Uh, Messages communication will happen between multiple threads of your program, right? So you'll understand these concepts once you write the programs. What is thread synchronization, and what is message passing or messaging. So let us first go to the practical program writing thing, and then come back. Then you'll understand this concept of messaging and thread synchronization very well with a practical program. So before going into writing the program, you need to know about some predefined classes that are available in Java core packages. So we'll see some predefined classes and interfaces and some methods which are defined in these classes, which will allow us to create programs in Java which are multi-threaded. That means each program will have multiple threads, and they'll be operating in a separate path, and they'll be performing different tasks concurrently. So that will be practically by running the programs also. I'll show you with example programs also all these concepts. So for that, for doing so, we need to know about the predefined classes first, right? So we'll in the next session we are going to see all those predefined methods, where they are defined, in which class they are defined, and where is that package. So which package we need to import into our Java program in order to write this multi-threaded programming concepts, right? So we'll see that in the next session. From now onwards, in your Java programming, all the concepts, new concepts that you're going to see will be depending on some predefined classes, and we need to import those classes from the packages in which they are available, right? All the topics that you're going to learn from now. Earlier, we didn't use any predefined classes much, only except in the case of uh, scanner class, which is available in util package. The remaining scenarios or in remaining context, we didn't use any predefined packages and classes except for reading input from the console by using the scanner class methods. Right? But from now onwards, we'll be extensively using in all the cases, in all the concepts, we are going to use predefined classes and methods. Right? So if you want to use them, you need to know uh, where these classes are defined, in which package they are put. If you know them, then you can import that particular package into your program and write that program, that concept. Okay, so we'll meet in the next session.